Hi everyone. At TriggerMesh, we're building a cloud-native integration platform. What does that mean? It means that we see the future of cloud-native application as being the integration of cloud services, the integration of different SaaS that are out there, and the integration of application that could be on-premises. So it's really a game of linking all those services together, of mashing them up. It's almost as if we were back in the days of Web 2.0, except that now we're 10, 15 years later, we have Kubernetes, we have microservices, we have the rise of serverless in the public clouds, and we need to take advantage of it to get one step further in the way that we architect applications. So here I am logged into the TriggerMesh actual staging environment, so just to show you the cutting edge. And here I see my dashboard. You see that we can create bridges. The TriggerMesh bridge is this application flow that links event sources to targets. And with this, by creating a bridge, we can create those integration of cloud services. All right? So what I want to show you today, just right now, are a couple integration that we did with GitLab. All right? So we work with GitLab very early on to help them develop the GitLab serverless feature in the GitLab application. But we also developed the GitLab event source, which means that we can have GitLab as one side of our bridges. So the first thing you want to do to be able to use GitLab within TriggerMesh is to create a secret and add your GitLab token, your API token. All right? So you've gone to GitLab, you've created a token, and you can add it to the TriggerMesh interface. Once you have this GitLab API token in, you can start building bridges. And you see that we have three bridges here in my current setup. So two of them are using GitLab, and those are the ones that I want to show you today. One is GitLab to ZenDesk. It's the very beginning of a very exciting bridge that helps you sync issues from GitLab with ZenDesk tickets. All right, that's our one bridge, and it's really the beginning, and I'm very excited about it, even though it's very fresh. Right? So syncing GitLab issues and ZenDesk ticket. The one at the top here, GitLab to Confluent, that's taking GitLab commits and it's putting them in a Kafka cluster running in Confluent Cloud. All right. So why would you want to do this? You want to do this if you want to keep a populated data lake of all your software activity and then run reports on those activities and potentially keep track of additional audit logs and things like this, right? So you're basically storing all your GitLab logs, all your Git activities inside your Kafka cluster running in Confluent. All right. So I've created those bridges before, and you see that here in our editor we have the event source that's set up, which is the actual GitLab event source. We have a set of brokers, and then we have the target. So we're going to Confluent at the end. And just as a kicker to show you the power of the platform, we're also sending those logs to AWS Lambda. All right? So we actually have two targets in this bridge, just for the fun of it. What is a bridge? A bridge is an API manifest, right? Or it's an API object that we've built at TriggerMesh. It's an extension of Kubernetes under the hood. It has the power of being declarative, right? And it has the power of Kubernetes. So here you see that our bridges is made of a set of components, and you see different components like a broker to manage the event, triggers, and then we have an AWS target to reach a function in AWS Lambda, and a Confluent target to get to Confluent. We also have a GitLab source, okay, because we're trying to integrate GitLab. If you want to actually see those full YAML files, you can go to TriggerMesh bridges, and then you'll see GitLab to Confluent and Lambda, and you see the source of the manifest that you could kubectl apply to your own TriggerMesh account, right? So you see the bridge and you see the full manifest. You see the GitLab source, which is open source as part of Knative, the different triggers, And then the targets, the AWS target, this is, available on the TriggerMesh SaaS, as well as the Confluent target available on the Confluent SaaS. All right? So what do we want to do? We want to make a commit in GitLab. We want to see the image come to Confluent, and we want to check the logs of our function. So in my terminal here, I'm going to consume events in my Kafka cluster in a topic called GitLab records. So let's consume those. It's going to sit there waiting for messages, right? Okay, do like this. And then I'm going to make a commit, right? So web IDE in GitLab, we take the README file, we say, hello people, and we commit. We commit directly to master or main. Don't do this. You should do a merge request, right? Here, boom, we've done a commit. I go back to my terminal. I'm consuming image. Boom, here you go. I get the GitLab event, right? This is the actual JSON objects that was emitted by GitLab, sent to our GitLab source in TriggerMesh Cloud, which we then injected inside our Kafka cluster running in Confluent. All right? So with this bridge, with this connection, you can keep track and hydrate a data lake of all your development activity, and then start building all the reports that you want for analytics, of your development speed and so on. On the Lambda side, technically, this Lambda received also the event, right? So this was my Lambda window. I open the monitoring. I'm going to CloudWatch. My Lambda function is not smart. My Lambda function is just dumping the event. So 1833, right? That's the one, and we can check the commit. So CC90D3, that was the hash before, and yeah, CC90D3. All right. So I hope you see what happened here with this bridge, which is described, declared as an API kind within TriggerMesh. We were able to consume all the GitLab commit events and automatically send them to two targets, AWS Lambda and Confluent, right? Great. That was our first bridge. Let's go to the second bridge, GitLab to ZenDesk. So same thing, you see that we have the GitLab event source. We could configure it with the type of events that you want. You see that here we are only getting events when you create an issue on the GitLab side in the repo sebgoa demo, and you see that you're able to do this because there is a secret which contains the GitLab API token. So you configure the source, and then you go all the way. You get two triggers actually. One is going to ZenDesk, so that's going to create a ticket on the ZenDesk side. I have my ZenDesk window here all created. I've created a secret which contains my ZenDesk API key. All right, so I'm ready to go there. It's a little bit slow, to load. And the bridge is also sending it to Sokai. All right, so Sokai is a little debugging capability. So, it's a little app, and when we do the issue, we're gonna see the event in Sokai, in this web app, but it's also going to create the ticket in ZenDesk. All right, and it's really, the beginning of this bridge. So what do we want to do? We want to go back to sebgoa demo, and we want to go to issues, right? We have no issues right now, only 4 issues closed, and we say, hey folks, this is syncing with ZenDesk, right? So I create the issue in GitLab, right? Boom, issue created in GitLab. That should emit an event. Boom, I got the event in my Sokai, which means that I also sent the event to ZenDesk through my target. My target prepared the payload so that it could create the ticket in ZenDesk. It's reloading. Boom, I have the ticket in ZenDesk created less than a minute ago. syncing from GitLab. All right? So I think this is very exciting, and hopefully you think so too. I just showed you two bridges, right? Two application flows that use GitLab. One is doing a syncing of issues to ZenDesk tickets, and the other one is sending all the GitLab commit activity to Confluent or AWS, right? So, you know, the integrations here are extremely powerful, and I would love to hear if you're interested by those application flows and work with you to make them even more powerful. Thank you.